So as it says, you do have a test on Wednesday. I've broken people up into blocks. I think you can see it, where there is one block for the regular time, one for if you're on Pacific time, one if you're in Central time. So if you see yourself in the regular time and you're not taking then send me an email just to make sure. If you can't see the block, then I'll let you know. So as it says, the material is chapter 5, although, oh, so if you go into groups, I think, this is where I'm checking. So actually, if someone can, why don't I wait a minute? Why don't I see if, oh, okay, there we go. Because I was going to say, if I can't find it, I can just say who's in which block. But, okay, so yeah, so check on that and let me know if you're in the wrong place. So the material is chapter 5, although 5.1 sequences was on the last test. So I put a couple on the review because it's part of the series, but that really isn't on the test. So there won't be a question like that. 4.6 is the radius and interval of convergence one, power series. 3.1 is distance displacement if you have one dimension. 3.3 is same thing with more than one dimension. 3.5 is volume, and then 3.7 and 3.8 are mass and center of mass. And to get too many examples, I said all that's going to be on it is just the wires. So before I start going over some of the examples and so on, any general questions about the test? Actually, I should say, I will probably make it so you can get to it at 9:05. I don't know how many of you have class before, but so if you can get in earlier, you can start earlier. And probably have it open until 10:30. So give you a little bit more time. So if there are technical issues, as with the quiz, although this time I'll set it up correctly. Last on the quiz I messed it up. If you do have problems uploading it, then just send me an email of the image. As I said, it's a little bit easier if you can do it as a PDF, but if you can't, don't worry about it. And in general, on the file itself, put your name. That way, if it gets separated, it'll be obvious whose it is. Okay, so what I was going to start with, kind of like test one, is there are two things that haven't been on a quiz. So I want to go over those because those are new. And then you'll let me know about other ones. So the ones that we haven't on a quiz are 3.5 and 3.7 and 3.8. So let me start with those. And what I'll do is, since you have the answers for the actual review, let me take the question from 3.5, which is number 9, and just revolve it around just different axes. And actually, let me change a little bit anyway. So it's y equals x. Y equals 2 minus x. And it is x equals 0, but let me change it. As I said, change it because you have the answers to the actual one. So let's make it y equals 0. So that way when I do the y equals x, now that I'm looking at it, I don't think I want to, which I'll draw and then you'll tell me why. So I'm going to switch it back to x equals 0 because what's the problem? So with what I have right now, this would be the area. So if I'm revolving that, why is that a problem for us? Yeah, the upper function changes, which means we'd have to break up the integral into two pieces, which in some ways isn't difficult but we haven't done it, so I'm not going to make you worry about it. So as I said, let me change this back to x equals 0. So this is the region we want. Now there's one bottom function, there's one top function. I suppose I could have made it x equals 2 or something. So let me make it a part C. So we have done x equals 4 on the x-axis. So let's revolve it around the y-axis. So first question is, for this one, do we want to do washers or shells? Yeah, so this is shells. As I said before, you can always do it with one if you want, but it's easier because you can leave everything in terms of x. So remember for there, our area volume thing is this. So first little thing, you should have found that this is the 0.11. So therefore, this will be the integral from 0 to 1. Which pi obviously doesn't change. What is r in this case? It's the base one, so therefore r is just x. I should know that there's a delay in there's a bit of a lag, so sorry about that. And what is the height? So x, right? So the x, so the 2 minus x. So it's the top curve, which is in this case the 2 minus x minus the bottom curve, which is x. So this is kind of the generic one. The shells is 2 pi times the radius times the height. And in the base model, the radius is x, and the height is the top curve minus the bottom curve. So we did x equals 4. Let's do another of these, and then we'll go to the other way. So let's do about x equals -3. So this is parallel to the y-axis, which means we're still using shells. And which changes? Does one of the two is going to change, either r or h. Which changes? Yeah. So I'll leave space to put it in, because you'll put that in a second. So the height does not change, so that stays there. What is the new radius? So x, that's supposed to be a 3. X plus 3, right? Because we've added, here's the radius. It's the x plus the 3. So now with the one in the review, we've done the 3 types if we're doing either the y-axis or something parallel, which is we did the y-axis, we did to the left, and in the actual review, it was to the right of the object. And again, you will not be doing one where it's in the middle. So you wouldn't be doing around x equals a half or something like that. So this is the other 2 types of shells. So any questions on either of these? And I should say, obviously what my answer is first. I should say that on this one, you'll just set up the integral for the test. You can see this actually isn't difficult. This is a fairly easy integral, but just have you set up. So any questions on this? Okay, so the other type. So we did the x-axis, so let's do something below. So in some ways, by default, you know what this is, but let me ask anyway, which is this shells or washers? Yeah. So x-axis or something parallel is going to be washers, and the area for that is pi r squared. All of these, the limits are going to be 0 to 1. And so in some sense, we have the same question as the other one, which is what's the top curve and what's the bottom curve. But now we are going to have to split it up. So it's going to get messy if I put it in. But you can see if I draw this line from where our axis for rotation, we hit twice, and so we're going to have 2 radiuses. And so the question is, what is the bigger radius? So 2 minus x and then plus the 1, right? So we get pi r squared. Obviously, on the test, if you want to simplify that, it's 3 minus x. That would, of course, be fine. And then the smaller one is the x, and again, plus the 1. Since the pi is in both of them, if you want, you can pull the pi outside the integral. Since we know that the integral of sums or differences is equal to the sum or difference of the integrals, you can make this into 2 separate integrals. But unlike the previous 2, we can't combine it in a nice way unless we actually square things out. So here's washer 1. Any questions on this? And you should be able to guess what I'm going to do next, which is we did the x-axis. This is below, so now we do above. And then we've done all the types. If you don't combine, so it depends on what you mean. So for example, what I've written here, I haven't combined them in some sense. So pretty much whatever I've written, you can do. So for example, I have the 2 minus x plus 1. That is 3 minus x, but you can leave it like that, if that's what you're asking. Okay. So now above. Again, there's a line. You can, again, see I'm not going to put it in because it makes it messy, but you can see it hits the my area twice. And again, this part of it doesn't change. So here, what is the bigger radius? So since we're measuring from here, that's where we're rotating. The further one away is x. And then again, the closer one. And we know that the distance between 2 points in one dimension is always the bigger number minus the smaller number. Hence the 5 minus 2 minus x. And again, you can simplify that. That obviously is 3 plus x, but you do not have to for the test. In general, if I say just set up an integral, once you've done all the preliminary work, you don't have to do anything else. So for example, when we do distance, if I give you the position function, then you have to get the velocity, which means taking the derivative. So you have to take the derivative, but once you plug it in, you don't have to square anything like that. So you have to do any preliminary work, same type of thing if you're doing total distance as 1 dimension, which is you have to find where the function is 0, so you can split it up. So you actually have to split it up, but you don't have to do the integral. So with these, now we've done, there are kind of the 6 cases, the x-axis and above or below, the y-axis and left or right. So any question on any of these? On the test, there'll probably be 2 of these, again, where you set it up. That probably means there'll be 1 of each, something parallel to the x-axis and something parallel to the y-axis, but I could try to trick you by doing 2 that are parallel to the y-axis, for example. Yes, it did 1. Oh, wait. Oh, the x-axis was on the actual review, so I'm doing ones that were not on the review. So any questions on this? Okay. So the other type that was on the review and will be on the test, but we haven't done, is mass and center of mass. We'll only do 1 of those. And the reason I don't have a problem doing it, even though we haven't done many examples, is the one that I said that could be on the test. And I'll just do a new one as opposed to what's on the review. I'm not sure how many questions are on the test yet. So, because partially it'll depend on how long I make them. So this is the only one from 3.7 that I could give you, that I'm going to give you, which is a wire has density given by something like this. Then find the mass. So for a wire, how do I find the mass? It's just the integral of the density, right? So we're just going to do the integral from -1 to 5. So really easy for a wire. The mass is the integral of the density. The idea is, remember, we're assuming, which you don't need to remember, but that the dx essentially is the volume, because we're assuming the cross-sectional area is 1. Dx is the length of that little piece, so the 1 times dx is the volume. So the usual mass is equal to density times volume. In this one, since it's really simple, I very well might make you do the actual integral. I could make an integration by parts, but I won't. So I'll probably keep it simple like this one. If I don't ask you to get it, then just label it, because you'll be using it in the next part. So label it like I did here. M is equal to that. So again, find the center of mass. So how do I find the center of mass? So let's start with the setup here, which is, it's similar to the setup in part A, except what else do you put in? So it's the integral of x times the density. And then we have to divide by m, right? Here, because I made this into an exponential, this would be integration by parts. If I gave you something like this on the test, I would just have you set it up. And if that was true, this would be fine as an answer. So as I said, as long as you label what your m is, as I did in the previous part, you can just leave it as m. So if I ask you to set up A and just set up A and just set up B, then the double underlined ones would be fine as answers. Oh, so x, remember what we're getting here was we're basically getting the average value of x. So the x is the value. So it's all the values from -1 to 5. So we're multiplying x, and then the 5 e to the x over m is the weight of that point. So we're finding the weighted average of all the values from -1 to 5. So this is 3.7 and 3.8. There is more to 3.7 and 3.8, which we'll talk about on Thursday, but this is all that could be on the test. So any questions on this? As I said, for this, I don't mind putting it on because even though we haven't done many examples, it's pretty easy, hopefully. So pretty much those are the only ones we haven't had a quiz on. So the only ones I definitely want to do. So let me stop and ask if there are any questions on these two topics. So any questions on either this or the volume? Oh, I should have said when I was doing volume. There are the other types for volume where you get the cross-sectional, you're given the cross-sectional area. It will be a volume of rotation. Okay, so here is this. And now at this point, it's going to be, if you remember test 1 review, probably something similar to that, which is now I answer questions and you stay as long as you have questions. So, and as with test 1 review, you can either ask a specific question about one of the ones on the review or ask me about a type. Because at least for some of them, I can pretty easily make up alternates. So any questions on a type or a problem from the review? Or just in general question about the test? 2i. Okay. So you wouldn't have to do absolute convergence versus just normal, but in a second after the 2i, I'll talk about that it might make something easier. So 2i. This, and that first one is k squared, which is important. So as with any of these where there's multiple pieces, it's a good idea to talk about, well, what does it act like? Have an idea of whether it converges or diverges. So this acts like what? So for the numerator, what's the only part that really matters? The 2k, and then the denominator, just the k squared. And that obviously now I can simplify. And what is that? You have two ways of saying that it diverges. Either it diverges because it's harmonic, or it diverges because it's p-series. So whichever way you want to say it. So at this point now, the problem is we can't say exactly what's going on with the original, although we really do. So we have to compare that to what we think it acts like. And we have two choices. We can either use the limit comparison, where we look at the ratio of the two, and as long as that limit is anything except for 0 or infinity, they act the same. Or we can use the regular comparison, which is if we say it's converging, we want to find something that's bigger, that's easy, that we can easily say converges, because then the smaller one also has to converge. And the other is if it's diverging, we want to find something smaller, that's easy, that we can easily show goes to infinity, so obviously the bigger one does also. I find the limit comparison nicer because as long as you've chosen correctly, the limit of the ratio is always going to be 1, which means they're always going to act the same, and you don't have to worry about trying to make the numerator bigger or smaller, and the same thing with the denominator. But you could be made to, and this is why you're made to, because if you think about it, if I look at this, if I look at the ratio, for large K, the K squared is going to kind of cancel out, but then we're going to get plus or minus this number, which goes up and down. So this one you can kind of say that the limit is 1, but if instead I made it, this one you can, sorry, but if I made it like this, two plus cosine over k over k plus 6k plus 8, then that would not work because now the numerator is either plus or minus 2, 2 plus or minus 1, and so it's jumping back and forth. So actually, let's do this one instead. So this one you can do limit comparison, sorry. So this is kind of a better example for what I was looking for, which is the original acts like the 2 over 6k, which is harmonic, which means it diverges. But now if I tried the limit comparison, it wouldn't work because the 2 plus cosine of k is sometimes 3 and sometimes negative 1 and sometimes in between, sometimes 1. So the limit comparison doesn't work. So instead what I have to do is, since I know this diverges, for the same reason, I want to find something that's smaller. So, and simple. So if I want to get something smaller, I want to make the denominator, the numerator, smaller. So what's the smallest the numerator can possibly be? So here, what's the smallest the numerator can be? Yep. And now since I want to make it smaller, I want to make the denominator bigger. So how can I make the denominator bigger and yet simple? And the idea is I'm just going to do this. So it's k is obviously bigger than 8. And it's now simple because this obviously combines. And now that is, I don't really have room to write it all here, but this is now obviously again the harmonic, so it diverges. And this original one is bigger than something that goes to infinity, so it also must diverge. So the idea is, if I have something like this, I can't really use the limit comparison because the limit's going to be going up and down. Well, so the idea is, obviously I've changed the series, but by making it a k, I've made it smaller because I made the denominator bigger. So I'm not looking to keep it the same. Obviously, making it a different series, but I'm making a smaller sum. So obviously 6k plus 8 is smaller than 6k plus 8k, and therefore the one is left. On the left is bigger. So something like this, the original one you actually could have used the limit comparison. Something like this, you might have to use comparison. So usually ones that make you use the actual comparison are things that involve sine or cosine, because those go up and down, or something like a plus -1 to the k, because again, that will make it go up and down. So the original, yes, it could have, because for large k, I started writing and thinking about it, and I thought, oh, well, if I multiply it out in the numerator, I get 2k squared plus k times cosine of k. Well, for large k, the second term is tiny. It's going up above and below, but it's tiny compared to the k squared, so you can just ignore it. So this is 1, so the limit comparison would have worked. So on the so actually in my answers I messed up 2 ways. So I'll have to correct this. So on the answers, I use the comparison, which isn't wrong, but you can use the limit comparison. And I changed the numerator from k squared plus 5k plus 8 to k squared, but that's making the denominator smaller, which is making the sum bigger. So that should have been k squared plus 5k squared plus 8k squared, so we can combine them all. Yes, and you should say what test you're using. So here, I just don't have room. I should say comparison. So sorry, so I'll have to fix the 2i because I messed that up. So any questions on this one, which is one where you're made to use comparison? So the cross-sectional area is not going to come up. A simple term test. So first, any questions on this? Because I'll erase. Okay. So the term test. So the term test only works says if I have the sum of a sequence and the limit of the sequence is anything except for 0, then I can say it diverges. So for example, in the last one, the limit of the terms is 0. But remember, that's not good enough, so then I have to do another test. So in some ways in the background for all these tests, the first thing to do is look quickly I'll leave off the limits to see if the limit of the terms is 0 or not. So for example here, the numerator acts like 3 times k factorial, denominator acts like k factorial. So I'm going to be lazy and let's call this k. So in some ways, you should be kind of looking at all of them quickly, because even though it's not on test, figuring out what the limit of a sequence is should be really quick. It should be something you can do in a few seconds. So I look at this and I can see, well, the limit is 3. That's not 0. I'm done. If the limit is 0, then term test doesn't tell you anything. So you can only use the term test if the limit is not equal to 0. So any questions on this? All right, any other questions? So if someone is paying attention, if you, since I messed up 2i, if you don't see it by sometime mid-afternoon, if someone would send me an email to remind me to correct that. Thanks. Wait, what will not be on? Now I'm confused. So when you say this will not be on test, what either did I say or do you think I said? The convergence test? Oh yeah, no, the sequences. So something like this. Oh, okay, yeah. So yes, so sorry about that. Saying is that for this one we use the term test, and you should be looking at that for each of the series, because even though sequences are not in the test, the limit of the sequence you're going to be using, you should be looking at for each of the sums. Sorry about the confusion. Any other questions on this? Okay, so let me erase. And any other type that you have questions on? I'm trying to think of what else. Oh, sorry. Yeah, I missed your question, telescoping. So in some ways, telescoping, because there just aren't very many examples, probably won't be on the test, but we can do it. So here's a quick example. And I did the one example where there are 3 terms where you had to do a diagonal to show that it canceled out, but I won't put something like that in the test. So something like this would be as far as it is. And for this, remember, you do not want to simplify. And so you just keep writing out terms. So what is the first couple terms? So if I put in k equals 3, I get and in some ways to see the pattern, I'm going to leave the denominator 6, even though obviously it does simplify. And on the test, if it came up, you would need to write as many terms as needed to make it obvious that there's a pattern. And here you can kind of see that the 3/6 is canceled 2 terms later by the positive 3/6. The negative 3/7 is canceled 2 terms later by the positive 3/7. And so everything's going to be canceled except for, so I would start writing census telescoping sum. Right. Rewriting him. It was lagging, so I wrote over my own stuff. So I get that. So whatever that is. 27 over 20. Okay. So you can see there isn't too much. About the only thing I can do is make it wider. So if I made it k+1 and k+5, then they would be 4 apart, which means you probably have to write out something like the first 6 or 7 of these to show the pattern. I wouldn't do anything that far apart. Any other questions? As I said, if you remember the test 1 review, this is kind of what happened. So if you think you're ready, so as I said, if someone is good enough, if you look in a few hours and you don't see 2i corrected, if someone can send me an email, that'll help. Otherwise, we're mostly done. So I have the usual office hours today from 1 to 3. And again, the reminder, which is I'm going to open up the test at 9:05. So if you can start then, that's fine. And I'll leave it open until 10:30. If you do have problems uploading onto Blackboard, then again, you're going to send me an email. And if possible, save it as a PDF with your name in the file name so that it's easy to put them together. Also, tomorrow is the usual day, so I'll also have office hours tomorrow from 1 to 3. No, that was on the last test. So Taylor series, Maclaurin series were on the last test, so not on this test. So all of chapter 4 except for 4.5, I think I said 4.6 at the beginning, but 4.5 was on test 1. So any other general questions? Okay. All right, so I'm going to stop recording, but as I said, basically now it's like office hours. So if you're ready, you'll come in on Wednesday, obviously just the test.